Hello, friends. Welcome once again. Welcome, all of you. Welcome, welcome, welcome. So, in this video, our main focus will be learning and revising surds and indices, one of the very hot topics in school days. Correct? So, let's get started without wasting any time. So, friends, you might not have direct questions or surds and indices in many exams, but they obviously form a big some small part of big calculations and other parts of the other questions. Okay, that is why it is good enough to know these basics, right? So all right, let's see. First thing, what do you mean by index? Number of times the base is multiplied to itself. For example, 5 to the power 3, it simply means 5 is multiplied 3 times. So this power 3. So okay, one more thing. What are the other words for index? Come on. Index can also be called as power. Yes. Or it can also be called as exponent. So you should know all these three words, right? Index or power or exponent. So this simply tells us the frequency. Frequency of what? Whatever the base is, that is 5. How many times it is going to be multiplied with itself? Multiplied. Okay, multiplied. So base is 5, index is 3. Okay. Also, you should be aware about this structure. What do you mean by 5 into 3? I know you will say 15, but technically 5 into 3 implies addition. Addition. So 5 added 3 times or 3 added 5 times. So when I say a to the power m versus a into m, big difference. Here there's only multiplication. So a into a multiplied with itself m times. And here we can have two observations. What? Correct. A is getting added with itself m times, or m is getting added with itself a times. So henceforth, there should be no confusion in these two structures, especially in the topic like log. This will be used. Yeah, you should know the difference between these two structures. All right. I hope you are up with your notes, pen, paper, everything. You are making the notes properly. Okay. Laws of indices. Here we go. A to the power m multiplied by a to the power n. The main thing is multiplication continues. So a got multiplied m times, a got multiplied n times, and both of these are also getting multiplied. Means a is ultimately getting multiplied with itself m plus n times, isn't it? Yes. Next, similar logic, right? A is getting multiplied totally m plus n plus p times. So m plus n plus p will be the new index. All right. Then we have a to the power m divided by a to the power n, divide by. Simple. Yeah, a is getting multiplied m times in the numerator and a is getting multiplied n times in the denominator. So out of those m a's in the numerator, n a's from the denominator got cancelled, right? So how many a's will remain now? M minus n times. A will be multiplied m minus n times, isn't it? So the new index or the new power is m minus n. For example, 2 to the power 4 divided by 2 to the power 2. So 2 was multiplied 4 times. Okay, friends, divide by 2 multiplied 2 times. So ultimately, 2 is multiplied 2 times only now, which is nothing but out of 4 terms, 2 terms got cancelled. Yes, I hope you understood. Now, a to the power m bracket to the power n. This simply means a to the power m into n. So here you should know very well that base over here is a to the power m and power is n. It means a to the power m will be multiplied with itself, yes, n times. Then how will you deal with further? Yes, use the first rule, first or second. M plus m plus m plus m n times. And how do we write m plus m plus m plus m n times in a compact form? Yes, m into n, isn't it? That's why I told you those two structures. Remember, a to the power m versus A into M. All right. So far, so good. Comfortable till here. These four rules. Awesome. Okay. Now this design, this symbol, we read this as nth root of A. Here, n is called as order of the surd. Root sign is called as radical sign. And A is called as radicand. So you should be aware about these few terminologies. Yes, friends. And this simply means A is raised to the power 1 over n. So fractional power. Okay. So whatever the order is, the reciprocal of that becomes the power of A. All right. So similarly here, A to the power P is the base, and then to the power 1 by n. And since there's a bracket, so both these will be multiplied. So A to the power P upon n. Okay. Yes. And this negative power is 1 over A to the power n. When the power is negative, this is how we deal with it. Yeah. And A to the power 0 is 1 except A equal to 0. Or else just delete this. Sorry. A should not be 0. 0 is to 0 is not defined. You understand this. Why so? Since childhood, we have just by hearted the thing that A to the power 0 is 1 always. Accept it without any prejudiction. Yes. But now let's understand the logic behind this. Sometime back we did A to the power m divided by A to the power n, which was A to the power m minus n. Yeah. Now just imagine like this. A to the power m divided by A to the power m. So when m and n are equal, don't you feel so? This will give me A to the power 0 and both these numbers are equal, so they will get cancelled. So I'll get 1. Yes, this is the simple reason. So the power 0 simply tells us the number got divided by itself, isn't it? And in the index form, how will you write this? 1 minus 1, isn't it? Got it? Okay. Now, A to the power n into A to the power minus n will be what? According to our first rule, A to the power n minus n, which is A to the power 0, which is 1. A to the power n into A to the power minus n are both are reciprocals of each other because their product is 1. And that is why the next step is this. Got it now? Yes, friends. Understood the logic finally. Why anything raised to 0 is 1. So here you can't have 0 now because 0 divided by 0 is not defined. That is why this condition. Okay. All right. I hope you have noted all this properly. I'm going to erase this. You can pause the video and note it. Cool. Yes. So ultimately, what are surds? So whenever the power is fraction, power is in the form of fraction, then, yes, then that thing is called a surd. Okay. Ultimately, surds, you can also call it as irrational numbers, non-recurring, non-terminating decimals. See, root 4, this is an exact answer. 4 to the power half. You know, now when nothing is there means by default there is 2. And 4 means 2 to the power 2 raised to 1 by 2. 2 gets cancelled. So 2 to the power 1, that is 2. So power is not a fraction. So this is a rational number, isn't it? But on the other hand, if you think about square root of 5, so 5 to the power half, now you can't do anything further. So power remains fraction. So this is an irrational number. Means if you think about the actual answer of this will be a non-recurring and non-terminating decimal. I hope you remember in our numbers, first lecture was all about this only. Yes? Okay, friends. All right. Getting the difference between the surd and not a surd? Yes. Fractional power means it's a surd. If the power is not a fraction, so ultimately it's a rational number, so which is not a surd. So surds are essentially nonsense numbers, irrational numbers. All right. Okay. Just two more. Very easy. A into B is the base and power is M. So A into B into A into B into A into B M times, which essentially means what? Come on. A is getting multiplied M times and B is also getting multiplied M times. So you can spread the powers. And here also same logic. A got multiplied M times, B got multiplied M times, but B is in the denominator. That is why B to the power M. Of course, here B cannot be 0 because it is in the denominator. So this you can look at it as power is getting distributed. So basically 6 square is same as 2 square into 3 square because 6 is 2 into 3. Okay, friends. Yeah. So x into y square is same as x square y square in that way. But hold on, x plus y square is not just x square plus y square. I hope you know this. Plus 2xy is also there, right? So be careful. So you can distribute power in multiplication only, not in plus. This becomes binomial. And we have discussed in detail about binomial in algebra series. Okay, you can refer the playlist of algebra and you can see binomial theorem. Yes. All right. Let's go ahead. I hope you have understood till now all these 10 rules proper, sorted. Cool. Now, some logical thoughts. If a to the power m is equal to a to the power n, then what can you say about m and n? Bases are equal, so powers will be equal, right? But some conditions apply. In these three cases, we can't say that because simple logic. So 1 square, 1 cube, both are same, but powers are not same. Minus 1 square and minus 1 raised to 4. Can you see? Both are same, but powers are not same. 0 square, 0 cube, both are 0 only, but powers are not equal. That is why I just remember that except these three cases, rest in all the cases, this will apply. Okay. All right. Now simply reverse. If the powers are equal, how will you relate the bases? So here just be careful. There will be two cases. A will be simply equal to B if the power is odd, and A will be plus or minus B if the power is even. For example, see A cube is 5 cube, then A will be only 5. You know that. 125. So taking cube root, A can only be 5. A can't be plus or minus 5 because minus 5 cube is minus 125. Correct? So if it is A cube equal to minus 5 cube, then A will be only minus 5. So here there is a uniqueness. Correct? Nothing about even powers. A square is 25. Now 25 can be 5 square or minus 5 square. That is why A is plus or minus 5, right? All right, friends. Yeah. If you have x square is 16, so x is plus minus 4. X raised to 4 is 16, so x is plus minus 2 because 16 is plus minus 2 to the power 4, right? So be careful whenever there is even power, there will be two possibilities: odd power, unique case. This will really help in some tricky situations. Fundamentally strong. You need to be fundamentally strong, right? Okay. This one is interesting. Initially, we might feel when we see this as there is a printing mistake. Bracket type karna bhul gaya. So you might put bracket on your own and you might treat this as that only and solve further. But that is not the right situation. Here you know that the base is a to the power m and power is n. So a to the power m was getting multiplied n times. We discussed this some time back. I think fourth rule was that. Here, first you should understand that base is a and the power is m to the power n. So this is the power and this is the base. First get this clarity. Yeah. And the comparison between them, it all depends upon the value of a, m, and n. Let's see the examples. This is 2 raised to 6, right? And this is 2 raised to 2 cube. 2 cube is 8. Of course, 2 to the power 8 is a bigger number than 2 to the power 6. In this case, we got this relation. Yeah. Check this. 0.5 raised to 6. versus 0.5 raised to 8. Of course, 0.5 raised to 6 is bigger than 0.5 raised to 8, because 0.5 raised to 6 into 0.5 into 0.5 ना, तो वो और कम हुआ, into half और reduce हुआ. For these kind of numbers, as the power increases, value decreases, right? Yes. Did you see now? This inequality is now, this part is bigger basically. So same inequality doesn't exist every time. And you also have this kind of relation. This is 3 to the power 4. This is also 3 to the power 4. So both are equal. So you can see all possibilities exist. It can be less, it can be more, it can be equal. It all depends upon what type of values are there for A, M, and N. So be alert, be careful. Yeah, so 2 to the power 3 to the power 4. This is not same as this. I hope this is very clear now. So here this is 2 raised to 81 and this is 2 raised to 12. In this case, I can write like this. Okay, clear, comfortable. All right. Next is rationalize. What was the aim of rationalization? Converting an irrational denominator into a rational one. Okay. How do we do that? We use the conjugate wala logic, right? So this is a plus b. So the thought is a plus b multiplied with a minus b gives me exactly two terms where each term is getting squared, right? I just want to square this, I want to square this without getting any extra terms. So that is possible only if we do rationalization. So every time you need to just create this in the denominator. So a plus b was there. So we introduced a minus b. So of course, value cannot change. We are changing the format, not the value. So essentially, we are multiplying with 1 only, and multiplication with 1 doesn't change the value. So a plus b is there, multiply with a minus b. So ultimately, a square. Acha, you multiplied in the denominator, so of course, multiply in the numerator also. No? That is why it will become 1, right? So you can't just multiply in the denominator. Yeah. So a square minus b square, so root 5 square minus root 3 square, so 5 minus 3, which is 2, and 2 fours are, yeah, and then open the bracket, so you'll get this. So here the denominator is 1, right? Upon 1. So initially the denominator was irrational, now the denominator is rational. This is the aim of rationalization. Okay. All right, friends. Next and the last variety over here is square root of the surds of the type a plus 2 root b. Something like this. So a plus 2 root b. If I want to find the square root of this type of surd, then how do we proceed further? Simple logic. Yeah. I'm going to get something whole square inside the root. Then only that root can be removed, right? Yeah. So if it is like a plus b the whole square, then square root, then we have a plus b. Yeah. How do I achieve this? Now, you know very well a plus b the whole square is a square plus 2ab plus b square. A square plus b square we should obtain from this, and 2ab can be obtained from this. Means we need to think about two numbers whose addition is 7 and whose product is 12. Yeah, of course, very easy. 4 and 3. So I wrote 7 as 4 plus 3 and we wrote 12 as 4 into 3. Split it. Now see, 4 can be written as 2 square, 3 can be written as root 3 square, isn't it? And root of 4 is 2 and root of 3 is root 3. Okay. A square plus b square plus 2ab. So we got that structure finally. Yes, we can write that now as a plus b the whole square. So 2 plus root 3 the whole square. Now we can easily remove the root. This is ultimately 2 plus root 3. Don't do the mistake of plus or minus. It's only plus. You should know that root of, if you write root of x square is ultimately mod x. So result can never be negative. See, if it is like this, x square is 16. The next step, which we generally skip, that is why we get this confusion. We write it right now here, x is plus minus 4. So we feel that root of 16 is plus minus 4. But root of 16 is only 4. Hold on. Next will be x is positive square root of 16 or x is negative square root of 16. Square root of 16 is only 4, friends. Square root of 16 is only 4. Plus or minus are already there because of the process of taking square root. And anyway, this was degree 2. Hence, we were expecting 2 answers and we got 2 answers. If they give me y is equal to square root of 49, means they are giving me this possibility. It will be only 7. Or they can give like this, y is negative square root of 49, means minus 7. Be careful. This was already square root, means this is already positive square root. So answer should be positive. Be careful. Here if there was negative sign, yeah, then I would have got like this. Simple. So you just have to create a plus b the whole square or a minus b the whole square inside the square root. For that, we should have this 2 very important number, 2 outside root wala part. Okay, got it? Cool. Thank you. One more example. In this case, first observation, 2 is not there inside. So how will you introduce that? Yes, first for 2 to be outside, inside the root, you should have 4, right? So 4 into what? 63. So this is nothing but root 4 into root 63, so which is ultimately 2 into root 63, right? Now this becomes a standard format. So split this. So two numbers should add up to 24 and their multiplication should be 63. So 21 and 3, right? Yes. Then you know very well a square plus b square minus 2ab. This is a minus b the whole square. The bigger number should be a. So ultimately, the answer of this will be root of 21 minus root of 3, not the other way. Positive square root. Okay. Got it? Yes, friends. All right. I hope you understood whatever we discussed in this Surds and indices concepts. Yeah. So in this our numbers module, first one was all about classification of the numbers and other things. Second one was divisibility and all. Third is this Surds and indices. Next one will be, stay tuned. You'll come to know. So I hope you have understood, you have followed. Thank you so much for your precious time. Keep learning, keep revising. Happy learning. Take care. Bye bye.